Hey again everyone, back with another Tortoise TTS video. I've been poking around the AI Voice Cloning WebUI a little more and trying to work on training in languages other than English. I certainly don't have this solved, but I'm going to share what little I've done in case anyone else is hacking away at it. This video is going to be a little less straightforward than some of my others. There's no real process to follow here other than modifying a few Python scripts. The rest is really up to your choice of data and training parameters. When you launch the WebUI, you'll see in the console output that it tells you which tokenizer is being loaded. The author of the WebUI had some great foresight and built a token tester that can be found on the Utilities menu. Going over to that tab and putting in some text will instantly show how it's being tokenized by the selected tokenizer. The default tokenizer can be switched in the Settings tab, which I'll do shortly. But first, let's turn a chunk of text into a whole bunch of numbers. You'll notice that some words are being chunked into only one or two tokens. That's normal, and an efficiency of the byte pair encoding tokenizer. What seems odd to me is the distribution of merges, and how they don't really match with what would be a normal distribution in a large body of English language text. I think this tokenizer was built using the included Red Riding Hood text that's in the Git repo. It can turn English words into tokenized sentences, sure. But what happens if we throw some non-English Latin character set text at it? Well, let's find out. Oh well, that doesn't look as good as the other one. The characters aren't even correct, and where'd all my accents go? Well, they're stripped out by the text cleaners. When you input text into the UI, some Python functions, the text cleaners pretty it up before turning it into tokens. Okay, so just disable that and you're gold, right? Well, no, not quite. You can disable the cleaners and then you can get the text to the tokenizer, but the tokenizer has no concept of how to map those never before seen foreign accented characters. When it encounters a character it hasn't seen before, it is assigned the unknown token. You remember all those words that were broken into only one or two tokens? Well, those subword chunks are currently mapped to tokens in our tokenizer configuration, and our configuration has limited space. And it's also currently full, and the mapping is trained into the current distributed model, so if you alter the token mapping, you'll end up with complete gibberish speech. Here's what that would sound like.
Jack was hungry. He walked into the kitchen. He got out some eggs. He took out some oil. He placed the skillet on the stove. Next, he turned it on the stove. Next, he turned on the heat. He poured the oil into the skillet. He cracked the eggs into a bowl.
Well, that doesn't sound as bad as it could. More complex or infrequent words are more likely to be mispronounced. This is actually the tokenizer I'm using later on, so it's a little more refined than my first attempts when being used on the original model. So my plan was to make a terrible, inefficient character map tokenizer for the Latin languages, then I'll test it to make sure it's actually tokenizing things. Then I'll have to assemble a clearly spoken English language, widely varied dataset and fine-tune the model until it can decode the new token mappings I'm presenting to it into speech. I'm using English because I don't have large enough datasets of other languages at the moment, and I'll be able to easily assess the output. Then I'll take that fine-tuned English checkpoint and try to fine-tune other languages. Just a little evening project, you know? So here's the problem if you're going to follow along here, and it's really only a problem if you want to share models. You'll need to share the tokenizer mapping JSON file as well. The tokens here will differ from the original included model, and if you use the original tokenizer, not the one the model was trained with, you'll get incorrect or nonsensical output. Now I'll go over the code changes, which can be as little as 2 lines depending on how elaborate you want to get with text handling. There are only 2 files you need to alter to change the text cleaners used by the WebUI. In the modules, Tortoise TTS, Tortoise, and finally Utils directory, open the tokenizer.py file. The definitions for the text cleaners begin around line 100, and around line 200, you'll see the preprocessed text function. Change English cleaners in the preprocessing function to basic cleaners. The other file to change is voice_tokenizer.py found in the modules, DLAS, then DLAS again, and finally audio subdirectory. Around line 70 in voice tokenizer, find the preprocessed text function, the else exception, and change English cleaners to basic cleaners once again. To switch to the new tokenizer, place it in the model/tokenizers directory, go to the settings menu, refresh models, and select it from the drop-down menu at the bottom. You may need to restart the WebUI after changing the tokenizer or model. On my system, things become a little unstable after I switch models. You can train your own tokenizer using Hugging Face's Transformers libraries, but I'm not going to go over that here because that would require a tokenizer per language at best, and I want to see how this character mapping performs with various languages. In this Tokenizer JSON, each character is mapped to a token value, and there are no merges. It really is as basic can be. and I'll link it down below in the description. So that's all there is to this super simple tokenizer. The changes made to the code are much more permissive about what text is allowed in, so transcripts should be as accurate as possible. There's a billion things to talk about when it comes to text cleaning, but they're all profoundly boring, and my YouTube watch percentage is already terrible. I think the most critical here is to go through your dataset and spell out all digits and dollar amounts, because basic cleaners won't transliterate them, and even when it does, dollar amounts can be said several different ways in spite of being written the same. Mistranscriptions can really throw off your dataset. Also, be careful about how sentences are punctuated. Ideally, your dataset doesn't have any clipped sentences, and you can place commas at the end of the clean sentence fragments. Long pauses may benefit from being transcribed with a comma, and trailing speech should probably use ellipses. If you find that your fine-tuned model is making weird noises at the end of sentences, check to make sure your punctuation is accurately transcribed. The only large multi-hour datasets that I have are English. I need something to train on to test and see if the new tokenizer is going to work. So I'll retrain the base AR model on an English-speaking voice and see how that goes. After training, here's what it sounds like.
We had to grow dreads to change our description. 2 copses on the milk box missing. Show they toes, you know they got stepped on. A fist full of bullets, a chest full of Teflon. Run from the pole, each picture that beep this, I'm too fat. I muck around and catch a asthma attack. That's why I bust back. It don't faze me. When he drop, take his Glock and I'm sways. Z.
Similar to other fine-tuned models, this is subject to catastrophic forgetting, which is just what it sounds like. The new information obscures or pushes out the old information. It does seem to be able to speak English quite well though, so this may serve as a good base to attempt to train other languages, but I guess I'll just have to try it to see if it will work or not. I think it works, I can't be entirely sure because I don't have large datasets for languages other than English, and I only speak English fluently.
Bonjour, Madame la Lune, que faites-vous donc là? Je fais myriade de prunes pour tous ces enfants-là. Bonjour, Monsieur le Soleil, que faites-vous donc là? Je fais myriade de groseilles pour tous ces enfants-là.
Ciel rouge le soir, laisse bon espoir. Ciel rouge le matin, pluie en chemin.
L'arc-en-ciel est en fête, car il porte sur sa tête un doux de tous les couleurs, comme celui de ma petite soeur. Violet, indigo, bleu, vert, jaune, orange et rouge. L'arc-en-ciel est en fête. Les couleurs sont sur sa tête.
These 3 voices were done with the same model. The French voices are the first time I've managed to get a multi-speaker model trained well enough that each of the voices seems to be able to produce consistent output. I was probably using too many samples for the computed latents. With very clear voice samples, fewer seem to work better than more. With a noisier dataset, more samples in the voice directory for the conditioning latent seems to work better sometimes. This was trained in 2 stages. First, I trained a single French speaker with approximately 2,700 samples of 1 to 3 seconds in length for 20 epochs. Then that checkpoint was fine-tuned using a dataset of around 18,000 samples of 1 to 3 seconds in length for 5 epoch. To assemble the large dataset, what I did was first transcribe each voice separately using the WebUI. Then in the training directory, I created a new directory for the mixed speaker dataset, and then copied each audio folder from each processed speaker to the new mixed directory, so all of the files were in a single audio directory. Next, I copied the contents of the train.txt files for each speaker into a new train.txt file in the new mixed speaker directory. And finally, similarly combined the whisper.json file for each speaker, minding the curly and square brackets to keep things formatted correctly. I think this is working alright, but still needs more training. This is using basic cleaners, and I didn't transcribe the digits, so the model has no idea how to handle numbers. The French model had a little more training than the other models I tried, so it doesn't make as many random noises at the end of sentences, but it does go a little walky at times. If your model is making weird noises at the end of sentences, try raising the length penalty slider a little, found under the experimental settings menu. After running a lot of training sessions over the past week, I can say that it's really hard to generalize information about training the model. A lot is very dependent on your dataset. However, one thing that seemed to crop up is that less training with a very large dataset is more effective than more training with what I'll just arbitrarily describe as a small dataset. For example, multi-R datasets that may have some noise or a few transcription errors seem to perform better than higher quality smaller datasets in general. Regardless of dataset size or parameters, assuming they weren't hugely wrong, there was a sharp decline in model improvement when training in English after one epoch. The French model took longer, as mentioned earlier, about 5 epochs, but there is a possibility it was better earlier as well. Unfortunately, I don't have the available disk space to store multiple checkpoints. I assume French took longer because of the characters and sounds that have never been encountered by the model. In the English tests, continued training after more than one epoch seemed to rapidly degrade the performance of previously seen voices. This happened even if the original dataset was extended with new data, meaning that I left the old data in the dataset. This degradation also happened when a completely new dataset was used on top of a previously fine-tuned model. This made it very difficult to train new voices on top of old. I did numerous training sessions with datasets of various sizes, different learning rates, and batch sizes. Datasets of over and are handle multiple epochs better, but the long training time here means I can't realistically do comparisons between models to evaluate things more. With datasets of an hour or so, or smaller, one epoch seems like it may perform best. This may be hardware dependent, but it seems that batching with sizes over 32 and grad 16 results in worse performance. This could have been differences between datasets, since I didn't do A/B testing with this either, but this corresponds to the fastest batching on my system as well. Here's a sample from one of the multi-speaker tests that's been training. For this I took the normal autoregressive model and trained a single speaker voice, which I've named cities, for one epoch using the new tokenizer. For this first session, the text learning rate slider was set to 1.
Keith recently came back from a trip to Chicago, Illinois. This Midwestern metropolis is found along the shore of Lake Michigan.
After training, the model could only speak in this voice and was misspeaking quite a bit. This is to be expected since it was a small dataset, under a half hour. After that, I trained another speaker from a larger 1-hour dataset, again for one epoch. For this session, I adjusted the text learning ratio back to 0.01. After this second session, the model was able to speak using both voices, although there are still quite a few errors in pronunciation. When training onto other models, I found it easiest to copy the model checkpoint from the fine-tuning session folder to the AI Voice Cloning Models Fine-Tunes directory. You may need to restart the WebUI and refresh the browser window after copying the model to make sure it shows up in all areas of the WebUI. Now, I'll be doing a third training session on top of this second model, using a mixed dataset from 30 speakers. I'm not sure how long this dataset is exactly, but it's made up of about 10,000 samples ranging from 1 to 7 seconds. I don't really want to delay this video any longer, so I'll try to post a separate follow-up with samples from that third training session if it turns out. The tokenizer linked down in the description is what I was using for training. If you are doing any of the Latin character set languages and want to try a tokenizer with no merges or tokenized vocab, give that a shot. You will need to make code changes, as shown earlier, and will need to switch to a new tokenizer before training. If you are sharing a fine-tuned model that used an alternate tokenizer configuration, you will need to share that with your model as well. It seems like it will work, but keep in mind you are essentially training the new language from the beginning, so it will take a large dataset. After a base language is established, you may be able to add on new voices by only training for one epoch. This is an open source project, so you're sort of on your own when it comes to things breaking. But if you have questions about the training done, or anything else covered in the video, let me know down in the comments. I'm going to end it here, because if I don't, I'll just end up endlessly editing for another week. If you found this helpful, please hit the like button, or subscribe if you want to see more of my nonsense. I don't even know what this channel is anymore. Anyways, thank you for watching, and for everyone that helped to get the channel over that 1,000 subscriber mark. I really appreciate it. Some of the ads YouTube forces you to watch can offset the power bill from running this GPU nonstop for the last 6 months. Back soon, probably with a final Tortoise TTS video before I revisit training your TTS again. Thanks for watching.